let's talk about how to go from standard form to vertex form. So let's choose a tough one. Let's say we've got x squared plus 3x plus 4. All right, you're familiar, A, B, and C. What we're going to do is we're going to try to put this into the format y equals A times x minus h quantity squared plus k. All right, which it does not look like that at all, right? Now, we can rest assured that for our problems today, A is going to be equal to 1. So in reality, we're really trying to get it to sort of like this hybrid between factored form, x minus h squared, and having a constant right here, almost like standard form. So here's how you do it. What you want to do first is you want to take, let's have x squared plus 3x plus 4. You want to take that b value and you want to put it into the formula b over 2 quantity squared. So you want to cut your b value in half. All right, so let's go right here step by step. So if my b equals 3 halves, or if my b equals 3, I'm going to take 3 and I'm going to cut it in half. And then, following the formula, I'm going to square it. All right, so that gives me the number 9/4. Now, I won't go too into depth with this because I want it to be a straightforward video. But in order to what we call complete the square, you are going to, once again, take your b value, cut it in half, and square it. So 3 divided by 2, quantity squared, well, that's 3 halves times 3 halves, or 9/4. So what's that 9/4 good for? Well, what you're going to do is you're going to modify your equation now. So you're going to take your x squared plus 3x plus 4, and you're going to introduce the number 9/4. You're going to add a magical number 9/4. But in order to not unbalance it, you're also going to subtract it at the end. All right? So we're going to add 9/4 and we're going to subtract 9/4. The next thing that's going to happen is pretty neat. What you're going to do is you're going to factor x squared plus 3x plus 9/4. All right? In other words, you're going to put this kind of into the box. All right? And you're going to say, well, x squared factors into x times x. 9/4, I should know what it factors into already because I just did it. That's going to be 3 halves, and that's positive, plus or times 3 halves. All right, which gives me 3 halves x plus 3 halves x. All right, which combine to give me 3x. 3 halves plus 3 halves is 3. All right, so what I have now is x plus 3 halves times x plus 3 halves plus 7/4. Because what I did right here is I combined my 4 with my negative 9/4. A little confusing, right? All right, last thing I'm going to do is, because these two factors are the same, I am going to write them as a single factor quantity squared plus 7/4. Now that seems really complicated to some. All right, I want you to notice though that my original parabola, x squared plus 3x plus 4, and my now vertex form parabola are the same. Look at the vertex. The vertex is at negative 1.5, which is negative 3 halves, and at a y coordinate of 1.75, which is 7/4. That's 1.75. Tough example. Let's take a look at one more. So what if I got x squared minus 2x minus 47? Let's apply the same formula. We're going to take b, the b value, cut it in half, and square it. Okay? So my b value is negative 2. I'm going to cut negative 2 in half. That gives me negative 1. I'm going to square that negative 1 so I get positive 1. Positive 1 is the value that completes the square. So notice how I throw in a positive 1, but remember, to keep it balanced, I'm going to have to subtract the positive 1. All right? Now, I'm going to take x squared minus 2x plus 1, and I'm going to factor it. Well, that factors into x minus 1 times x minus 1. I'm going to combine my negative 47 and my negative 1 to give me negative 48. And I'm going to clean this up to get x minus 1 quantity squared, take away 48. I'm going to check this. There's my parabola, all right, in its standard form, and also in its vertex form, where I can see that the vertex is indeed 1, negative 48. Perhaps the second example was more simple than the first one. That's how you complete the square to find vertex form.